Have you ever inherited a large amount of code where you needed to get up to speed quickly? Well, the Architecture Explorer in Visual Studio 2010 helps you do exactly that. I've loaded a solution here that has 6 projects and about 10,000 lines of code. I'm going to look at this code using the standard dependency graph feature that you'll find under the Architecture menu. This feature is built on the capabilities of the Architecture Explorer, and I'll take a deeper look at the Architecture Explorer in another video. But right now we're going to focus on these commands. There are 3 built-in standard graphs that you can generate. These are using different configurations of options that you'll see on the standard graph custom dialog. But right now I'm just going to use the standard graph by assembly. Here it's analyzing the 5 output assemblies, and it's looking for all the dependencies including type references, inheritance, method calls, and then it produces a high-level DGML graph document like this. Here we see the thickness of the links represent how many dependencies exist between these assemblies. And if you hover over the link, you'll see that there's a roll-up of all the types of dependencies that exist here. In this case, we see calls, inheritance, references, attribute users. If we expand the externals, we'll find out what this application is built on. Here we see it's using the presentation framework, so that's WPF. We can also see that it's using the service model, which is part of WCF, so it must be doing some communication. We can also see that it's using Team Foundation for version control and work item tracking. So Team Foundation Server for source control is being used. If we scroll down, we also discover something very interesting. We can see that there's MS Core Lib version 2 being used here, and MS Core Lib version 4 being used down here. Now if we expand this node, we'll see what from MS Core Lib is being used. If we expand this node and so on. It's important to remember that for the external assemblies, it's not showing you everything inside the MS Core Lib assembly. It's only showing what this application is using. And we can zoom all the way down to the method level. So this graph is actually packed full of information. And what we can do is we can expand all those nodes. This graph is about 1.5 megabytes on disk. And it has basically every method call and every class and interface and so on that it exists inside this graph. As I've expanded everything, if I zoom out, you get an idea of how big this graph really is. So there's MS Core Lib version 4, there's MS Core Lib version 2, and I'm just going to keep on zooming out. That's just the external bucket there, and I keep zooming out. Now we're starting to see the server, the client, and the generics, and so on. So this gives you an idea roughly also of the size of these code bases. The server's probably bigger than the client. The externals, as always with object-oriented programming, is the biggest bucket. So now that we have all this data loaded, we can explore this information to our heart's content using several different navigation tricks that I'll show you here. Not only can you use the mouse wheel to zoom in and out quickly, but you can also draw a rectangle with the right mouse button to zoom directly into that part of the screen and right down to the method level. You can select nodes and you can see what the cross-group dependencies are. You can navigate those links and jump to other parts of the graph. And this one will take us back down to this part of the graph and so on. You can use the back-forward navigation buttons to retrace your steps through this graph. You can also feel free to just delete whatever is not relevant to your exploration. For example, we might decide that the MS Core Lib is not relevant for the kind of investigation we want to do. So we can just delete that whole group and make the graph smaller, and that'll help make the overall navigation quicker, and so on. Perhaps also we don't care about generics right now and how generics are being used. If you look at all the collection classes, you can get an idea of what kind of data is being managed. But let's say we can delete the generics also, and again we get down to a smaller graph. Maybe it's now a little bit more relevant to the kind of investigation we want to do on this code base. Now another really cool trick for creating subsets of this graph is to click on a link. So in the standard graphs, the link represents a roll-up of all the dependencies. In this case, the dependencies between Yabra client and the interfaces assembly. If you click on the little plus sign on this link, it'll generate another standard graph where you can specify what you want in the standard graph, and it'll show you just what is creating that link between the client and the interfaces. If we expand all, we can see a subset of the graph we had before. If we select everything, we can see how tightly coupled the client assembly is to the interface assembly. So there's quite a few links here, probably about 50 links, and we can now zoom in and see exactly what in the interfaces is being used by the client. This graph is only about 50K on disk compared to 1.5 megabytes, so it's much smaller and much easier to grok. Now sometimes some of the most interesting links, dependency links to examine, are those between your application and the externals. Now I have to show you a trick here to make that work. The link click feature middle button only works between assemblies. This brown node is not an assembly, it's a logical group of external assemblies. So we have to remove that group in order to be able to click on a link and get details about a dependency. So let me collapse all of the groups again and get back to a high-level picture. And now what we see is just assembly dependencies without the logical grouping of internal, external. Now when you do that, it's handy to still be able to see what's external. So what we can do is we can use the legend to create a style to color the external code a different color. So we have it in green here. So now that we've done that, let's explore the dependency between the server and the version control, Team Foundation version control assembly. If we click the plus sign, we can ask for just the classes and namespaces and methods, no externals, just that dependency. So again, we get a much smaller subset. Again, this graph is about 50K. If we expand everything in this graph, we can see the Yabber server is doing something with change sets, it's doing something with version control, and it's doing something with shelf sets. Shelf sets are a really cool feature of TFS, by the way. A picture is worth 1,000 words. If we select all the nodes, it will show you all the cross-group dependencies between the server and the client. Clearly, this tells you it would be a lot of work to change the dependency on the TFS client here. Now another way to do similar types of impact analysis is to use the butterfly graph feature here, which can slice and dice this graph in different ways based on what you've selected. Now suppose you've been asked to add something to the Yabber client interface. All you've been told is to start with the iYabber client interface. You can see that there's cross-group links going off to various places within this very large graph. But what you can do is turn on the butterfly tree, make this the center of the butterfly, and it'll pull down close together all those things that are dependent on the Yabber client interface. You can see that there's a Yabber client callback on the client that, and you hover here, it implements that interface. So these are all implement links. You can see that on the Yabber server.exe, there's a remote server client class and a Yabber server service that implements this interface. So now you can see that there's a lot of things on the server that flow down through the Yabber service and might also have dependencies. So these dependencies go all the way back up through into various parts of the server. You can actually see a pattern here. There's a lot of classes here named task. So there must be some task concept that wraps up and funnels its way through the iYabber client interface. You can also see on the client side that there's a session context object and not so many client objects are dependent on the Yabber client interface. So quickly here we've gotten a fairly good idea of the impact of making the change that you've been asked to make in the Yabber client interface. So far we've been generating standard graphs using this menu from code that we've loaded in a solution. Now it's also handy to be able to generate standard graphs like this from a random assembly on disk. You can use the Architecture Explorer, which is available on the View menu here, or you can bring it up here, and you can select a random assembly. In this case, we want to learn a little bit more about the version control client DLL that we're using here. And so what we can do is we can open up that assembly, and by default it shows you what's contained in that assembly. So this contains column, if you click on it, expands and shows you other things that you can do with this assembly. And if you scroll to the bottom, you'll see that there's a special command called standard graph. This brings up the custom standard graph dialog. So what we can do now is we can ask for just types, so it'll be interfaces and classes, and let's say no methods, no externals, and we can open this up and say just show me the public and protected types and public and protected methods. In other words, show me the public surface area of this DLL, in other words, the API that I could use if I wanted to use this DLL. So it's analyzing the assembly, and it's building a graph. Now this graph is pretty big. We'll switch to the force-directed layout. So there's quite a lot of public surface area in the Team Foundation version control assembly. We can see from the force-directed layout that there's a couple of fairly big hubs that are the central concepts in here. And there we see the ShellSet class that we saw being used before. And again, you can go into butterfly mode and take a look at all the things that can touch shell sets. We can go into left to right mode again to get an even more compact representation. And here we see in a snapshot all the things that we can do with ShellSet using the Team Foundation Version Control API. So to sum up, the standard dependency graph feature of Visual Studio 2010 is a great way to get a quick idea of what is happening in some code that you haven't seen before.